Thanks. Hi, good evening, everybody. Thank you for staying up for so long. My session is going to be on IPython. Just show of hands, how many of us have heard about IPython? Okay, and how many of us have heard about IPython notebook? Great. I heard about IPython first when I was in Pune for 2011 PyCon. There I was introduced with the IPython console, and I could not do much with IPython console apart from using the tab completion feature and the document reading feature that it has at that time. But lately I have been involved with a lot of exercises back in my office where I need to do a lot of interactive and exploratory analysis of data I'm playing with. So that is how I got interested and interactive with IPython. So basically there are a few expectations from my talk that you can keep. I would like to make it interactive in terms of why do we actually need an interactive environment? Why do we need an environment where we need to interact? What is the difference between a normal Python console and IPython console, and how IPython notebook is different from every other environment that is available? A brief about IPython project, how many contributors are there, who uses that, and what kind of applications are there. Actually, IPython notebook is a brief understanding of the architecture, what lies under the hood, how the kernel works, how the processes work, how the communication happens between a web browser and the Python terminal in the backend. Then we'll get started with IPython notebook specifically, how we can use it with shell, empower us using shell and Python, use the magic functions, take advantage of the different display systems that we have in IPython. And it's going to be a lot of demos in my presentation. I'm actually going to write a complete notebook with all the features that I'm going to explain for IPython notebook today. I'll not be going into the nitty-gritties of any particular library in terms of NumPy, SciPy or Pandas. There have been already very good talks about it throughout the PyCon. So I'll be focusing majorly on the IPython notebook and its power. So let's just get started with it. Why do we need an interactive environment? These are some points that I listed when I started using, when I had the urge of using an interactive environment. First was, I wanted to introspect, search and move around within the modules and namespaces and understand how it works. But I wanted to reduce my switching between my browser windows, my Python console, within my Python console to the shell command, and I wanted to reduce my switching timing between it because it was just taking too much amount of time. Open an editor, write a code, then move back to the console, type a shell command, then go back to the editor. So I just want to minimize my switching time between that. Whatever analysis I was doing on my interactive prompt or the interactive shell, I wanted to make it reproducible. I wanted to go back to the commands that I have typed earlier, take a backup of it or probably write them in a file and then use it again. Either use the input again or use the output again. I wanted to be collaborative, right? So I work in a team. I did some analysis on my data. Now I want to share that data, right? So how do I take that data from the soul and share it among my team members? So IPython notebook comes in very handy when we talk about collaborative sharing among peers or with others anywhere. I can also take notes within the same notebook in terms of I can write textual data as well, save it as a text format. We are going to see what different formats of objects can we represent when we talk about the display systems in IPython. So that is also one of the important features of it. All said and done, I have done my exploratory analysis. Now I want to take my findings to my managers and share it with the seniors. What do? I need to make presentations again, right? Now taking all the data out from the console to the presentations is again a big hassle. So I wanted to minimize that as well. So IPython notebook again helps you minimizing that effort and take your findings and research not only to peers but in a presentable format as well and present it to your seniors or managers or editors. And you as a user will have your own use cases and own need of an interactive environment. So the IPython project started in about 2001 by Fernando. The guys who started IPython project were primarily scientific computer users who wanted something because scientific computing involves a lot of exploratory analysis. So they wanted some kind of a shell where a lot of interaction could happen. So that is when the project actually got started off. In 2001, there was only an interactive shell that was available. There was nothing like Qt console or the IPython notebook. But slowly, as we have reached 2013, there are 3 front ends of IPython that are now available. We'll be talking about that as well. Some few funds that have been raised for IPython project. So architecture and components. Before we actually moved on to the IPython notebook, just a brief about the architecture and how underlying code works. So IPython kernel is what runs on your server, on your machine. That is what is running in the backend. right? It has a two-process communication model which interacts with the client. So treat client as your web browser and IPython kernel as the core engine that is running on your server, right? So this web browser makes a connection to the kernel. So this web browser is essentially your notebook, right? So each notebook has its own kernel process running in the backend, right? Now they use 0MQ and Tornado to actually do the communication process. So when you give an input at the notebook, it goes to the kernel, it executes the code and returns back the output. So that's the two-process communication model that IPython notebook uses. Traditionally, there was a single process between the terminal and the kernel, but then when Qt console and IPython notebook evolved, now they are a separate process. So each notebook will have a separate kernel. Okay, I was talking about front ends. So this is one of the front ends that came into existence when the project started. So this is the normal IPython console. So even if you have IPython installed on your system, if you just type IPython, this console will open up on your system. It is also interactive. There are a lot of features that are common between IPython console and IPython notebook. There are some features that are browser dependent. For example, you want to display images, you want to create graphs, you want to take videos from YouTube, etc. That is only possible in the notebook. That is not possible over here in IPython console. But still, the kernel remains the same. All right. So when you are doing coding work on IPython notebook, you get a kernel ID. You can come back to a console and still the console that open that kernel ID. So what I'm trying to say is, whatever stuff you do on a notebook, you can access that in your console as well. That is the power of IPython. The other console that came before IPython notebook was Qt console. It is still into existence. So Qt console is again for some GUI work that you want to do. You want to graph some basic graphs, etc. So there where the Qt console comes into the picture. What is going to be the main feature of today's talk is IPython notebook, which we are going to show us now. So some features of IPython notebook: you have in-browser editing of the code, where automatic syntax highlighting, indentation at tab is there. You have the feature of introspection that is really important when you're doing interactive programming. You can use shell and Python together. So you can write a shell variable, access it in Python. You can declare a Python variable, access it in shell. So I usually call it shell with Python brain. Then you're going to see a lot of magic functions. Magic functions are nothing. It's a functions declared that come with IPython itself, and you just need to call them for various specific purposes. So I'm going to show you some key magic functions that are very helpful for at least me, and there are others available which you can use for yourself. Rich output display, non-blocking output of the kernel. What non-blocking output of the kernel means? So say I say for I in range 0 to 10 and I put a sleep in between, right? So it will not wait for all of the range to complete and then display the output. As soon as it is it is iterating, it will start giving you the output in the notebook itself. So it is not essentially, it would wait for the whole execution of the program to finish and then give the output. So in that sense, it maintains its state. Okay, let's move to the demos now. So this is when you start IPython. So I'll just show you how I started it. Okay. So when you start IPython from your server, this is what will get displayed in your browser. We call this the dashboard. So this dashboard has a list of IPython notebooks that you've already created. On the left side are the names of the notebooks that you've created. On the right hand side are the state of that particular notebook. So the message that says shut down, that means these two notebooks are already running for me. I've opened those notebooks. Now if I close my notebook in the browser, that does not necessarily mean I have shut it down. So you have to manually shut it down. Otherwise the kernel still runs at the server. So even if you close it up, it is not sure that you have closed down the kernel. So make sure you always shut down your notebooks. There is another feature of IPython which I'll not be discussing today because it's a talk in itself, that is known as IPython clusters. It is primarily used for parallel computing, where you can deploy multiple kernels or multiple machines and then execute a code in a parallel manner. So that is beyond the scope of this talk today. So I'll be focusing on IPython notebook on a single machine. Right. So let's see. This is my notebook. So if you see, this is the menu bar which has a lot of options over here. cell, kernel, help, which has all the shortcuts and everything else. So this block is essentially known as the cell, right? You write your code in a cell and each cell executes within itself. So when I write print hello and I press control enter, this will execute the code hello, right? So for example, I say print right? So this will say welcome to my talk, right? So this is happening as when I'm doing it. The question mark is for getting help. As I told, there's a sort of introspection that is being needed, right? This is one of the reasons I came to IPython. So question mark means I want to ask a question. So if I just type question mark on the cell and do control enter, it opens a frame for me which is separate from your cells. It opens a frame that has a definition of whatever function I have asked for help for. In this case, I have entered question mark, so that is giving the brief documentation of IPython notebook within itself, right? So this opens up the documentation of IPython. I can close it down or drag it down. For example, you say, okay, you have imported a module known as collections, right? And you don't know nothing about collections, right? So what will you do? Okay, so let's do this. I import collections, right? Then I say, okay, collections, I press tab, it completes it. Then I say dot, I again press a tab. This is listing me all the functions that are available within collections, right? But I don't know what collections is meant for. So I'll simply put question mark against it and press control enter. It opens the documentation for this, right? So this says it's a module, alright, that's good enough. Now I'll uncomment the previous line and do collections.name tuple. So the difference between question and question mark is double question mark actually opens the source code of the function itself, right? So if the source code is available within the library with you, that will get displayed here as well. So first I'll do a single question mark. This is what the help of collections looked like in the name tuple function. Now I'll do a double question mark. So you can see it's a brief documentation of what is there. This is just coming from the doc strings that are available in a particular function. There is no rocket science into it. So the Python inspect module reads the function and picks up whatever is written in the doc string. If you don't have any doc string written over there, it will not give you back anything. And now I'll put a double underscore against it. Right now you can see it is giving me a lot of source code with it as well, right? So double question mark will always help you. You need to dig into more details. Now in this, there are a lot of wildcard fields available in IPython notebook as well. So if I do star int star and then a question mark, so what I'm asking it to do is whatever commands I've executed till now, whatever libraries I've imported till now, or whatever variables I've declared till now, wherever there is anything that has int between it, just display all of that to me. So if I execute this code, so this has given me these 4 things, right? So these are the 4 things that has int between them. So again, this becomes very helpful when you're writing a lot of programs, or you've completed a lot of cells and now you maybe want to find a particular variable name that you've declared somewhere, right? So just do star your variable name, star or part of variable name, and question mark, that will list your variable name. In case you find some difficulty to start with IPython notebook, just do a %quick ref. Now % means magic functions that I was talking about. So whenever you see a command starting with %, that means it's a magic function of IPython, right? So %quick ref would give me a quick documentation of what. So it's like a cheat sheet for IPython, right? You would find all the powerful functions that you might be interested in right after doing the quick ref, %quick ref. Right? Tab completion. This is one point I mentioned, right? This is how I started using IPython. So for example, like collections module we did in the previous example, I'll do import OS. Then I'll again say os.work is the function I want to use, say, for example, right? Now when I open a brace and I press tab, right? So this gives me the function signatures, the arguments does the function accept. Okay, I've gone through them, but I want to know the further details. But I don't want the question mark to appear and then read the documentation. So I'll press a tab again. So this is the same documentation that was opened by the question mark, which I'm able to access with just a click of tab, right? So this again can help you read whatever the function accepts, what kind of variables it is accepting, and use the function. other feature we talked about was I want to maintain my history of the commands that I have typed, right? I might be wanting to use the input that I had previously given to the program, or I might want to use the output that I had received from the previous examples, right? So over here I do a simple addition function 2 plus 2. It gives me 12. Now this underscore means last output that I had received. So if I do a underscore plus 10, this means 12 plus 10, right? This means 22. If I use double underscore, that means the output previous to this command, right? And similarly, if you keep increasing your underscores, that will keep getting you the previous and the previous and the previous output. But that becomes cumbersome, right? How can you remember so many underscores? Not a problem. If you see the number on the left hand side, right, this indicates what cell number it is. Each cell is marked as input cell and an output cell, right? So you know input 21 and output 21. So I can use this definition and then call upon for functions. Right? So if I just do is underscore 24 is equal to output 24. Right? That means it's true. So what I'm trying to say over here is I want the output of 24, which is one declaration form of it. I can use underscore and the number of the cell, or I can use out and then the index number of the cell. So out is nothing, it's just a dictionary, right? So this lists the cell number and the output. Input is also a form of dictionary. You can have the similar controls on input as well. So if I just execute this code snippet, this will tell my last output was true, the next one was 30 and the next one is also 30. Right? My last input was out, my next input was underscore 24 is equal to out 24 and my input was underscore. Right? So this is how it maintains history within itself. History is again a magic function available with us in IPython. So if you do %history, this will open whatever is available, whatever you had typed earlier. So these are all the commands that I've been playing around with this particular notebook, right? So whenever I do history, that gives me all the lists of commands. If you do history, %history and the question mark, this will open up the documentation for history, and then you can see what all options are available as arguments that you can pass with the magic function history and do a lot of stuff with it. This was all simple magic functions and simple Python using IPython notebook. The other point that I shared across with you was using shell with Python, right? I don't want to move back to shell and switch back to Python again, right? I want that same power over here with me, right? So all I can do is this exclamation suggests that the command I'm going to execute is a shell command, right? So whatever I write after the exclamation mark means it has to be a valid shell command. Why I'm saying shell is because the server I'm using is a Linux box. You can do the same on Windows or a Mac OS as well, right? So I do a pwd, this lists me that this is my present working directory. Now I say, okay, list all the directories and put them in the variable files, right? Now this is a shell command that I executed and this has made it as a Python list that I have now, right? I can use the same variable and print it in the form of how I do it using bash script, right? I can use a shell command and use it as a Python function as well. So I want to say echo files. Now file was list, so I'm just taking up the 0th element, first element of the list and converting into uppercase. So here it is bin, so this would convert it into uppercase, right? So you can mix and match your shell and Python and do a lot of stuff with it. Let's move more in detail of the magic functions that we have. So if you just type magic, it will give you what IPython magic functions are available with you, and there are lots of them. If you do a %ls magic, I'll do it sometime later in the notebook. You'll see all the list of magic functions that are available with you, and see what works for you and what not works for you, right? When you see a single %, so there are two types of magic functions. One is line magic and one is cell magic, right? So when you do a single %, that means you want to apply a particular function only to that particular line, right? When you do a double % and the magic function is you want to apply that function all across your cell, right? So for example, I want to use it time it range. Now this is a single percent, so this is a line function right now. When I run it, it would time the function and return me back the result, right? Now if I do a double percent time it, now it is a cell function. So whatever I am writing in the cell, this will run the magic function against those instructions that I have given. You can even use the line magic functions within your code snippets. You don't want to use it at the start or at the end of your cell. You want to use it somewhere between your code snippet. So this is how you would do it. Right? A simple, so you have a magic function, cell magic function for bash as well. So you do a %% bash, and this is what I've executed. So this gives me my bash and memory status that I have on my machine. You want to write a file, but you don't want to switch to the console, do a BI or a Emacs and then write a file, right? How do you do it from your web browser itself? So there is a cell function called file. All you need to do is %% file test.txt or whatever the name you want to give it to your file, and just write the file, right? When you press Control Enter at the end of it, it has overwritten the text.txt file because I had created that file earlier, right? Now I will do add text.txt. This is what you can see the output. So probably let me just add another line. And do Control Enter. Now I'll do a cat on it. So here you can see it is the file that I wrote from web browser, and you can get the output of it again in the browser itself. List of magic functions, it's simple. You do a %ls magic and you get all the magic functions that are available to you, right? It has some kind of naming convention with it along. So whenever a magic function starts with %p, you can say that it has to do something with printing of the values or stuff like that, right? So it has a naming convention attached to it as well. When I'm doing programming, when I'm doing work on my IPython, simple Python console, the error messages that I get are not too communicative, right? Or I cannot play with them as much as I want to play with them, right? So there is a magic function that's available with us that is known as %x mode. That is majorly to tweak into your error messages and make them more descriptive or just reduce them. So for example, this is a file that I'm writing right now, mod.py. This has two functions, g and x, right? Now if I do mod g of x, obviously I try to divide it by 0, that is why it's giving me an error. It gives me a float division error. Now if you've ever used the Python console and done some programming on it, you will not see such descriptive message over here. That will be a simple message saying you've got a 0 division error over there. It will not give you the full traceback that you can see right now, right? So there are 3 modes of X mode that are available with us: plain, context and verbose. The default mode that comes is context. So this is a context mode output. If I go plain and try to run the same functions, now what I'm doing is I'm setting a line function which will apply to my cell, right? This reduces my traceback and just limits it to what function the error gave, what line the error had come to, right? I was using plain in this case. If I do a verbose, this will actually start printing my whole program and mark what all function calls did I make and where the error actually came, right? To set it back to default, you can just do simple %x mode and context. You can use debugging here as well. So PDB is available as a %debug is again available as a magic function to you. So all you need to do is add %debug and again fire that function. It opens up a IPDB console right in your browser, right? So if you need to use that, just use a command and type enter. You can start using your PDB console right over here. You can even do plotting in your IPython notebook. You must have seen in this year Python, a lot of presentations are being done on IPython, right? And a lot of graphs and plotting visualizations you see in the notebooks. That is one of the features that has made IPython notebook as a revolution. You can do visualizations within the same notebook. So if you import, so PyLab inline, I need to import and tell that I want to import all my Python graphing libraries into it. So NumPy, plot, matplotlib get imported using inline into this. And if you need to create a simple graph, just write the program, execute it, and you have your graph within your notebook, right? I have a lot of stuff with databases. So this is one of the extensions that I came across a few days earlier. This is known as the load extend SQL. What it is letting me do is fire SQL queries, native SQL queries from the browser itself, right? So all I need to do is I need to say load this extension, connect to this particular SQL. You can use Postgres here as well. I am using MySQL over here. So I connect to my database. It says I'm connected to the database. Now I'll fire a simple query that says show tables, right? So this is listing me all the tables that that particular database has. And furthermore, you can execute whatever queries you want to execute over here. You can even take the output of the SQL query into a variable. So what I'm doing over here is I'm taking this output of SQL, this query, into data variable. Now you can see I have listed down the keys as columns. I put them into data frame of pandas and do whatever I want to do with this, right? So all it will do is it will fire this query. Right, let me just. Right, so I've got select ID and final monitor name. So this is what you see as columns that I've got in my variable. So now I've got the output of the query that I fired from my web browser in a variable, and now I can play around with it by putting into pandas or whatever other library that I'm comfortable using. There are a lot of times when you copy your code from some different from a different prompt and paste it. But before doing pasting operation, you need to actually clean the prompts that you see, right? But you don't really need to do that when you're talking to IPython. Okay, just copy your code as it is. So, example, I've copied this code from a prompt and pasted into the cell. I really do not need to remove these tags. All I need to do is execute this code, and IPython automatically takes care of that. So that way, I really don't have to mingle around, pasting it into an editor and removing the indentations and the prompt signs and then doing that. The other interesting feature of this is, so this is all the cells that we've talked about are of cell type code. So if you see this combo box over here, it lets you treat your cells in different manners, right? So all the cells that we've talked about have been of the type code. I can even use markdown as my cell type. So all the text that you see, for example, IPython kernel model, this is all markdown type of cell that I have used, right? So if I select markdown over here, I can actually say, okay, I want to make it as a text. So I'd say run this command. So this is a text that I have now entered over here, right? Markdown is intelligent enough, so if you press a tab and define a function, so it will automatically indent it and present it as code snippet for you in your markdown cell. Last for this demo is connect info. So connect info actually displays your kernel process and your kernel IDs that I earlier mentioned you might want to use to export all this notebook to a particular file or import it into another IPython console or a Qt console, right? So all you need to do is connect info and use these values to play around with it. Second thing that I was mentioning about was the rich display system that adds value to the notebook, right? This is what is actually different from the IPython console that you have. A lot of things that we've talked about, the magic functions all are also available in IPython notebook, but this feature is what is very different from IPython console and makes IPython notebook way ahead of the rest of the environments that are available with us, right? So what you can do is you can display images in the notebook. You can display SVG files in the notebook. You can link local files as hyperlinks in the notebook. All you need to say is file link and the file name that you want to link to it as. You can even embed photographs as a offline storage. Okay, so there is embed versus non-embedded images. So if I do a embed, so that means I want this to be available on an offline. And when I do a soft link, it will always go to the original source and get the photograph for me. You can embed videos direct from YouTube as well. So there is a module known as YouTube video available with you, right? So if in your presentations you want to add YouTube videos, all you need to do is put the YouTube video link over here and your video gets added over here. In the newer versions of IPython notebook, it is getting more close to your web browser. So if your web browser supports video formats, you can even use the capability of your web browser to display your video. So you need not go to YouTube, upload your video first over there, and then embed that video in your notebook, right? You can simply use your HTML and tag the video there. These are simple HTML tables that you can create in your notebook. This is a CSV file. I've just written a file and depicted that as a table over here. You can even load external websites within the same notebook. So for example, you want to make a reference to a website. All you need to do is use the iframe and load that particular website into your IPython notebook. For the mathematician and statisticians, you can even use latex definitions and write down the latex functions over here in IPython notebook. So these were the demos that I had to showcase to you guys. The third-party tools and extensions are what lies over and above IPython notebook. There are a lot of third-party tools that are available as plugins and extensions that you can use to extend your IPython notebook experience. For example, I showcased you IPython SQL. That is what I use to fire SQL queries from IPython notebook to databases, right? Similarly, there is software carpentry which helps scientists build the software using IPython notebooks. So there are loads of tools and video tutorials available that you can use for your purposes. You can cloud host your notebooks. The demo that I'm doing currently is hosted out of my own laptop, right? You might want to host it on cloud and share the URL with among each other. So you can use PyCloud and Vakari as a feature for that. You can even use Amazon to deploy single-use notebooks over there. There are a lot of front end available. For example, in Vim itself, you have an extension that can help you load the IPython front end inside Vim. Similar things available in Emacs and stuff. Sharing and collaboration is another point that I mentioned. Why I need interactive environments. Right now, I am done with all my exploratory analysis. I want to share and collaborate among each other, right? So I can use to convert it into slides. So the complete presentation that you're seeing right now, I made it into IPython and converted it to simple HTML5 slideshow, right? It took me just a minute to convert it into HTML5 because IPython comes with that support within itself. Similarly, the way I created slides, I can create PDF and I can create HTML as well. So you see a lot of people now are who love to write code and love to write blogs as well. So they're writing IPython books and convert into HTML and then publishing to their blogs. Right? There's another application available, NB Viewer. Okay, so I have a notebook. I put it on my Git, or I've created a gist out of it and shared the gist number with you. Right now, you want to view it, but you don't want to go into the hassles of installing IPython in your system, right? So NB Viewer is a freely available application that IPython.org itself has created. All you need to do is you need to go there and share the gist number or the URL where .ipnb file is there. So .ipnb file is the extension of your IPython notebook. So if you just share the URL over here and say go, so you will be able to see that in the IPython view. I can show you example for that. So this is a raw file. This is the .ipnb file. So this is what looks like if you go back to the console and do a cat on your .ipnb file. This is how your notebook would actually look like, right? Now if you want to convert this into a pretty looking notebook, go to NB Viewer and paste the URL. This is what it looks like, right? So if somebody shares his or her .inb URL with you, you can just go to NB Viewer and view it over here. Obviously you cannot run your code over here, you can just do the reading, but still it is good enough for sharing and collaborating in that sense. People have written books on IPython. Books on IPython as in not what IPython is all about, but for example, there is a guy who has explained Bayesian statistics and published the book in form of IPython notebooks. So all you need to go and do is download his repo and start reading the book in form of IPython notebooks. So whenever he updates his repository, you can update your repository, and that is how he shares all the code snippets and updates with you. So this is what the book look like. This is another exercise. So this guy is teaching learned data science using IPython notebooks. So again, he's coded the examples and given given you in form of IPython notebooks. All you need to do is download them on your system and play around with that. Whenever there is a change in the code, you just update your repository and the code snippets are viewable again. So in this manner, collaboration and sharing become very, very easy. After the talk, what resources you can dig into is, there is a collection of interesting notebooks that the IPython repo has with itself, and that keeps getting updated with a lot of interesting work that is happening all across with IPython notebooks, right? So this is a sample of gallery that looks, and the number of projects that list over here are just exhaustive, right? It's scientific building, data science, financial work that people are doing. Any interesting work that people are doing on IPython is present over here. So this might be interesting for you to go and have a look at. Mailing lists are very active of the IPython community. There is only one mailing list. Earlier they used to have a couple of mailing lists for dev and for users differently, but now they've collaborated into a single mailing list. That is also a very valuable channel to absorb and consume information that is being shared across IPython, the roadmap of future IPython, how it's going to be, what is the future of IPython and stuff like that. Chat room is also very, so you will find some of the devs there hanging around all the time with any specific question that you have, which you cannot find on Stack Overflow or the mailing list. Just head on to the IRC channel of theirs, and they have lots of information there as well. Books and official docs are always available for you. Thank you. We are open for questions if there are any.
So you mentioned you can connect to the databases.
Yeah.
So Oracle also is supported, or not?
I'm not really sure of Oracle as of now.
Okay.
This extension that I'm using was released about 2 months back only.
Oh, okay.
Catherine is the developer for this, so she has not posted at yet what is the roadmap of the extension. So I'm not sure of Oracle, but Postgres and MySQL are surely supported.
Okay. So next question is, like, if I have a process in which it takes some time to really do it, so I still want to use my notebook during that point of time. So what can we really do?
Okay. So one code snippet that I did not show over here was, you can run your code snippet in background as well. Right? So you code your cell and you tell that I want to run this cell as a background process. So that will run that particular cell as a background process for you.
So if I start the terminal and then if I have to open multiple windows, is it different notebooks or it's going to be the same notebook that really comes out?
Okay. So yes and no. Yes, in terms of, if you open the same notebook, you will not be able to see the changes that you're making in various tabs, because the tabs do not get refreshed automatically, right? But whenever you open a new notebook, that will open another kernel process in the memory. But if you want to, so for example, I had a case where I was writing down a notebook and I wanted a scratchpad kind of thing, right? So what I did was, I showed you that you can pick up the kernel name and open a Qt console or a IPython shell. So you pick up that kernel name, open the Qt console, that becomes your scratchpad, do whatever you want to do and save it. That automatically gets back to this notebook. So in that sense, you are working on the same kernel, right, but in a different window. Not my presentation, I'll be sharing it in demo forward.
Konark, I have a question. Can you shed some light on how sandboxing works on the kernel side? So if there are 4 people all opening the browsers and typing in Python code, okay, how does it actually handle to separate the concerns on the server side?
So currently, there is as such no feature in IPython notebook. So last month itself, in the beginning of August, they released IPython notebook 1.0, which is also a single user notebook itself. So for example, you saw that I was using OPT as my direct, right? But I cannot give access to all and everybody to use that same IPython notebook server. In the roadmap ahead, they are working very aggressively on bringing multi-user environment into the scene. This is particularly your question. You want 4-5 users to work on the same server of the IPython, right? So they are still working on that feature, which is available at the moment. But there was a project by one of the universities which has written actually a shell wrapper that creates different virtual environments for you, and and then you can log in using your Linux security policies that helps you maintain individuality among the users. But that is not the official IPython project as such. The other thing to provide security on notebooks, for example, I mentioned you can put them to cloud or on your public facing servers. There is a configuration available with IPython. If you say I want to run this IPython notebook with a particular profile, in that profile you say I want security policies and this password authentication mechanism. I want it to be on SSL and all the password policies that you have. So in that sense, you can bring a password over it, but again, that will not help you with multi-users.
So you use this IPython notebook whichever your Django workflow, and how do you do that?
So not for Django. I was reading something on the mailing list that how people are using on Django, but I have not tried it. How to integrate Django on IPython. I mean, I don't really know how I write complete projects using IPython notebook. I would still go back to my editor and write my complete project there, right? But I would use IPython notebook when I have no defined specific task, right? I'm still playing around with logics and trying to understand the problem statement. That is why that is where the IPython notebook comes as a use for me. But when I know these are the following functions I need to write and what I need to write into them, I would go back to my editor and do that.
Any more questions? Thanks, Konark.
Thank you.
Yeah.